Today we will study quadratic equation and its related graph. How it is related with graph. So it is the graphical interpretation of quadratic equation. Let us see. Ax square plus bx plus c is equals to 0. This is the general quadratic equation. We all know. A is your leading coefficient, c is the constant term. So this is basically is the 2-degree polynomial, and this is known as the quadratic equation, and this is basically represents the parabola. What it represents? Parabola. Okay. It has the two roots, alpha and beta, or we can say zeros. Zeros or roots both are same. Okay. This represents the parabola. In this equation, if we consider first case a greater than 0 and d discriminant greater than 0. If discriminant a greater than 0 and discriminant is greater than 0, then the graph of this equation come out would be like this. Okay, a is greater than 0, then parabola opens upward. D is greater than 0, it means it has two distinct roots, maybe rational, maybe irrational, whatever it is. Okay, it has two distinct roots. Okay, if this a leading coefficient is less than if this a is greater than 0 but d is equals to 0, then what happens? This is the second case. Then the graph would be like this. It means that it touches the parabola, it touches the x-axis at one point. This is the x-axis. It touches the x-axis at 2 point. It touches the x-axis at 1 point, and both roots are equal. I mean, at 1 point it is touching the x-axis. Both roots are equal. Okay. A greater than 0 and d less than 0. This is our third case. In this case, a is greater than 0, parabola opens upward, d less than 0. It means that the parabola, the graph of this quadratic equation always attain positive value for all real value of x. For all real value of x, this ax square plus bx plus c is always greater than 0 for all x belongs to r. This is the sign for x for all x belongs to r. So it is, the graph would be like this. It always attain positive value. It always attain positive. It always attain positive value. Positive, positive, positive. Above the x-axis. Okay. And these roots are imaginary. Okay. Now, if we consider another case in which the leading coefficient of this quadratic equation, leading coefficient a is less than 0, d is greater than 0. If a is less than 0, the parabola mounts open downward. So it would be like this. Okay, it has two root alpha and beta, two distinct root, maybe rational, maybe irrational. If irrational, they are occurrent conjugate pairs, as we have discussed earlier. Okay. Second case is a is less than 0, d is equals to 0. It means parabola opens downward. Okay, it would be like that, and it has two equal roots. Roots are equal roots. Okay. In third case, a is less than 0 and d is less than 0. It means, it simply implies ax square plus bx plus c, this quadratic equation is always less than 0 for all x belongs to r. For all x belongs to r, it is always less than 0. Graph would be like this. It always attain, it is below the x-axis, always attain negative value. It would be less than 0. Okay. These are we are having the 6 graphs. Okay. Now we will take an example to understand the graphs we have discussed earlier. Okay. So example is here like that. The graph of a polynomial quadratic equation is given. 2-degree quadratic equation is given, and it attains maximum value minus b by 2a, and maximum value is minus d upon 4a. This is the x coordinate, this is the y coordinate. Here it is the root bar beta, here is the root alpha. This is 0, c. Okay. Now what we have to find, we have given the same, we have considered the quadratic equation as ax square plus bx plus c is equals to 0. This is the graph of this quadratic equation. Now we have to find the sign of a, b and c. So what are the signs of a, b and c? So first we will take we can see directly from the graph that c is greater than 0. We can understand. Okay, this is the first point clear. Second is, what about a? As parabola opens its mouth downward, it means that a is less than 0. And what about b? So B is somewhat little bit complicated, or we can say it's something tedious. So let us consider here. Minus B upon 2A is greater than 0. You can see it from here. Okay, this value is greater than 0 now. So minus B upon 2A is greater than 0 and A is less than 0. It is given that A is less than 0. If A is less than 0 and this is greater than 0 and this negative positive, it means that B is greater than 0. So what we get from this, we infer from the graph that C is greater than 0, A is less than 0 and B is greater than 0. We have such type of questions comes in our exam. It's a basically reasoning based question and simple. We can solve it directly if we have a knowledge of graphs. Okay. We can find the location of roots if we have given two roots and if one condition is given, and it's basically in technical term known as the location of root. It's the basically topic is known as location of roots. Location of roots. I will not discuss its all type because it's so ridiculous. You have to consider only 2 or 3 cases and you can find it out, because it's a obvious thing. You will understand after what I will teach you regarding this. Okay. If we have given condition, first condition is given that two roots of quadratic equation lies either side of unity. Okay, so first type, we can say type 1 to this. Okay, so type 1, either side of unity, that two roots of the quadratic equation lies either side of unity. Okay, so this is the unity 1 and 1. If one root lies here, either side of unity, this is alpha, this is beta. Okay, we can infer from this from our knowledge of graphs that we have discussed earlier that D should always be greater than 0. It should not be equal to 0, because one unit either side of unity, so it should not be like that. Graph should not be like this. Okay, this should not be valid. So D should, first condition is D should be greater than 0. Okay, and A should be greater than 0 if we have considered this graph. Okay, and f of 1 greater than f of 1 should be less than 0. Okay, because f of 1 value should be less than 0 if A is greater than 0. This is the first set of conditions. If in this case, I will consider this is the case first. If I will consider case 2, that is 1, this is alpha, this is beta, and f D is greater than 0. Again, A is less than 0 and f of 1 should be f of 1. What f of 1? F of 1 should be greater than 0. So this is the condition 2. If both roots lies on the either side of unity. In the similar way, you can find between A and B. Second type is if both roots of quadratic equation lies between A and B. A and B are two arbitrary number, anything A and B, and roots are lies between A and B. Okay, if both roots of the quadratic equation lie between A and B, so this is A, this is B, and both roots lie between A and B, it means like it would be like that. So D can be greater than equal to 0, because the graph should be like that. First, second case would be like this also. Okay, this is A, this is B. Okay, so in this case, f of A, f of B, yani f of A is greater than 0, f of B greater than 0. Okay, so we can collectively say that f of A, f of B multiplication should be greater than 0, this we can say, and D greater than equal to 0. This is the first condition, this is the second condition, and third condition is that the minimum value, that is x equals to minus b upon 2a, it would be lie between it would be lie between a and b. So minus b upon 2a would be lie between, I can consider it capital A and capital B since to avoid the confusion. Okay, so it would be lie between a and b. This is our third condition. Okay, these are the two types in location of root. If you will get these concepts clearly, you can solve any problem regarding quadratic equation. That's all. Thank you very much for watching my video. If you like it, please subscribe it, like it and comment below. Okay. ठीक है.